Hello dear students, in session 2 in the lesson of volumetric titration, we're going to study the application on the volumetric titration using color indicator, the titration of iodine solution with thiosulfate solution. Please prepare your notebook and the sheet found in session 2 while watching this video. Let's remember from the previous session how titration reaction between Fe2 plus and MnO4 minus takes place at the molecular level. Remember that the balanced equation of the reaction is as follows. So according to the equation, if we apply the stoichiometric relation between MnO4 minus and Fe2 plus, we can see that each 1 mole of MnO4 minus reacts with 5 moles of Fe2 plus. So every time we add MnO4 minus, it reacts completely. The added pink color rapidly disappears and Fe2 plus remains in excess. Until all Fe2 plus has reacted. This is the equivalence point. The volume added is called volume equivalence, VE. Fe2 plus is not in excess this time. MnO4 minus has also reacted completely at this point. We say that both reactants at equivalence point have reacted completely according to stoichiometric relation. But the color at this point is still colorless, so at macroscopic level we cannot know that we reach equivalence. A very small volume is added from the burette. This changed suddenly the color in the beaker from colorless to light pink without significant change in the value of VE. Here we stop and record VE. The MnO4 minus added after equivalence remain unreacted in the beaker. Their concentration increases as we add more volume and their color becomes deeper. So as a summary, as we add MnO4 minus from burette, it reacts with Fe2 plus according to stoichiometric relation. This decreases the concentration of Fe2 plus in the beaker until equivalence is reached. At equivalence, both reactants have reacted completely, and after equivalence, as we add more volume from burette, MnO4 minus becomes in excess. As for calculation, we say that at equivalence point reactants are in stoichiometry. Therefore, the number of moles of Fe2 plus initially in beaker over 5 is equal to the number of moles of MnO4 minus added from burette over 1. We can replace the number of moles by C times V. So instead of NFe2 plus, we say C times the volume of Fe2 plus over 5, and instead of NMnO4 minus, we can replace the concentration of MnO4 minus times the volume equivalence. Now let's titrate an iodine solution of brown color with sodium thiosulfate solution, which is colorless. What is the redox reaction that occurs between these two solutions? This titration is based on two reactants that are R2 and S2O3 2-. The redox couples involved they are as follows with the given value of E0. In order to know the equation that is taking place, we place these two couples on the electrochemical axis. We can see that I2 is a stronger oxidizing agent and S2O3 2- is a stronger reducing agent. Therefore, according to gamma rule, a reaction will take place between I2 and S2O3 2-, producing S4O6 2- and I-. So the balanced equation of the reaction, it will be as follows. If we calculate delta E0, we will obtain 0.538. Because this value is greater than 0.3, therefore the reaction is a complete one and it can be used in titration. At the beginning of the titration, we have iodine in the Erlenmeyer flask. As you can see, iodine has a dark brown color. Upon adding thiosulfate over iodine, iodine starts reacting and its concentration starts to decrease with time. So in each addition of thiosulfate, we can see that the color of iodine solution fades out gradually until it becomes very light and hard to be seen with naked eyes. So how can we notice the equivalence point? In fact, in this case, we need a color. So because it's so difficult to determine the equivalence point in this case without using a color indicator, the color indicator used in titration of iodine with thiosulfate solution, it is a starch solution. Iodine solution with a starch, it gives a dark blue color. And this dark blue color is given even if iodine has a low concentration. So, upon titrating iodine solution with thiosulfate, as you can see, the dark brown color of iodine starts to fade out after each addition. The color fades out more and more. We continue adding thiosulfate until reaching a light color. At this point, when we have a yellow light color, we add few drops of starch. Whenever we add the starch to the solution, a dark blue color appears. And this is because we have iodine in the Erlenmeyer flask. Now, we continue to add thiosulfate over the Erlenmeyer flask. Upon adding thiosulfate, we can notice that the dark blue color is fading out. We continue adding until decolorization takes place. So, to set up the titration apparatus, first of all we fill the burette by the titrant, which is S2O32- to the 0 mark. And then we put a determined volume of the analyte, which is I2, in the Erlenmeyer flask. We start adding progressively the titrant over the Erlenmeyer flask until the dark brown color of iodine becomes lighter. At this point, we add 1 milliliter or 2 milliliter of starch. The color of the solution turns to blue. We continue adding thiosulfate from the burette until the blue color disappears and the solution becomes colorless. At this point, we record the volume equivalence VE. So, according to this equation for the calculation, we say at equivalence point reactants are in stoichiometry. Therefore, the ratio of I2, which is N of I2 initially present over 1, is equal to the ratio of S2O32-, which is N of S2O32- added from burette over 2. So the calculation is done by taking these two ratios equal. Thanks for your attention. This PowerPoint was prepared by teacher Ali Bakri, recorded by teacher Zainab Yassin, and supervised by teacher Hiba Bada.